Question 1. At time t seconds, where t is greater than or equal to 0, a particle, p, moves so that its velocity, v meters per second, is given by v equals 6ti minus 5t to the power of 3 over 2j, and we're told when t is 0, the position vector of p is negative 20i plus 20j. Part A says find the acceleration of p when t is 4. We don't have a constant acceleration, so we can't use suvat. We are going to have to differentiate. So the acceleration we call A, is equal to dv dt. The acceleration is the velocity differentiated. So we can differentiate v. So that is, we differentiate the i's and the j's separately. So we times by the power, then take one off the power. So we've just got, well, 6 i's and times by the power, 5 times 3 over 2 is 15 over 2. And that's t to the power, we're taking 1 off the power, so that'd be a half. 3 over 2 minus 1 is a half, and there are j's. So that's our acceleration. We wanted to know the acceleration when t is 4. So we substitute in t is 4 into here. So we're going to have 6 i's. And for our j's, we can type this in the calculator, but we don't need to. 4 to the power of a half is 2. So it's 15 over 2 times 2, which is 15. So negative 15j. And the units, so they are in meters per second squared, or ms to the power of negative 2. Part B, find the position vector of p when t is 4. So to find the position, to find the distance travelled, we integrate. So we're integrating the velocity. So on a velocity time graph, the distance is the area under the graph. To get the area under the graph, integrate. So we want the integral of v with respect to t. So we're going to integrate, add 1 to the power, and then divide by the new power. So 6t squared divided by 2i, and we're going to add 1 to the power, so that would be 5 over 2, and then divide by the new power, and there are j's. So simplifying this, 6 over 2 is 3, so we've got 3t squared i's minus 5 over 5 over 2, so 5 over 2.5 is 2, 2t to the power of 5 over 2j, and we need to plus c because we're integrating. We can find out what c is because we've been given this additional information. When t is 0, the position vector is negative 20i plus 20j. So this is the position vector. So when t is 0, it should equal negative 20i plus 20j. So that's when t is equal to 0. So 3 times nothing squared is nothing. 2 times nothing to the power of 5 over 2 is nothing. So that leaves us with negative 20i plus 20j is c. So our displacement we can call s is 3t squared I minus 2t to the power 5 over 2j minus 20i plus 20j. We wanted to know the position when t is 4, so we substitute in t is 4, and that will give us our answer. So let's look at the i's first. So we've got 3 times 4 squared minus 20, which is 28. So we've got 28 i's. For the j's, we've got negative 2 times 4 to the power of 5 over 2 plus 20, which is negative 44. And that's a distance, it's measured in meters. Question 2. A particle P moves with constant acceleration 2i minus 3j. At time t equals 0, the particle is at the point A and is moving with velocity negative I plus 4j. So the initial velocity, that's u. At time t equals t seconds, P is moving in the direction, so in the direction of vector 3i minus 4j. So we don't know the velocity, but we know the direction it's going. So it's a multiple of 3 and a multiple of 4. So that's v, and t is, well, t. So v equals u plus at. So we're going to be using v equals u plus at. So v is 3xi minus 4xj, some multiple of 3i minus 4j. U is negative I plus 4j. And we've got at, so plus, well, t times 2i minus 3j. So we need to find t. We're going to do this with simultaneous equations, so let's split off the i's and the j's into two separate equations. So I'll expand this first. So 3xi minus 4xj equals negative I plus 4j plus 2ti minus 3tj. So let's split them off, have an equation for i's and an equation for j's. So for our i's, we've got 3x on the left side, and that's equal to negative 1 plus 2t. And for our j's, we've got negative 4x is equal to 4 minus 3t. So we've got an equation for i's, an equation for j's. We need to find t, so we'll eliminate x somehow. So if I divide my green equation, my I equation, by 3, so divide both sides by 3, and for my j's equation, I'm going to divide both sides by negative 4. So now I've got x equals and x equals, so I can make them equal to each other. So they're both equal x, so they must be equal to each other as well. So we've got negative 1 plus 2t over 3 equals 4 minus 3t over negative 4. So I'm going to multiply both sides by 3 and multiply both sides by -4. So that'll give me -4 times -1 plus 2t equals 3 times 4 minus 3t. Expanding these brackets will give me 4 minus 8t equals 12 minus 9t. That's plus 9t to both sides. So -8t plus 9t is just t. I then take 4 away from both sides. T is 8. And then we're told, part B, at time t equals 4 seconds, P is at the point B. Find the distance A to B. So A is where it started. A is the initial point. So we just need to know the distance travelled in 4 seconds. So we've got U. We know A, we know U, we know T. So let's make a note of this. So we've got Suvat. We need to know the displacement. We know the initial velocity was -I plus 4j. We don't know v. The acceleration was constant, 2I minus 3j. And we know t is 4 seconds. So SUANT, we can use S equals UT plus half AT squared. So let's substitute these in. S equals UT. So S equals U times T. So 4 times -I plus 4j. UT plus half times A 2I minus 3j times T squared, which is 4 squared. So let's expand these brackets. So -4I plus 16j plus, well, we've got half times 4 squared. So half of 16 is 8. So 8 times 2I minus 3j. So -4I plus 16j. So expanding this bracket, plus 16I minus 24j. And then just collecting the i's and the j's. So we've got -4 plus 16 is 12. 12 i's. 16 minus 24 is a -8. So 12 i's minus 8 j's. We want the distance. So we've got it's in vector format. So that's displacement. Distance, we need to do Pythagoras. So we need to do Pythagoras on this. We don't want something in terms of i's and j's. We just want so many meters. They were meters. Yep, so many meters. So we'll do Pythagoras. So the distance is, well, the distance squared equals 12 squared plus 8 squared. So the distance is the square root of 12 squared plus 8 squared. For root 13. So 4 root 13 meters. And if we wanted three significant figures, 14.4. Question 3. Here we have two blocks, A and B, of masses 2m and 3m respectively, and they are attached to the ends of a light string. A is held at rest on a fixed rough plane, so there is friction. The plane is inclined at angle alpha to the horizontal ground, where tan alpha is 5/12. So if tan alpha is 5/12, we can use that to work out sine alpha and cos alpha. So tan is opposite over adjacent. So opposite over adjacent. We can use those to work out the hypotenuse. That's one of the Pythagorean triples. So the hypotenuse is 13. The square root of 5 squared plus 12 squared is 13. And that means we know cos alpha and sine alpha. And I'll quickly note those down now. So cos alpha, cos is adjacent over hypotenuse, so 12/13. And sine is opposite over hypotenuse, 5/13. So the string goes over a smooth pulley, and the path of the string from A to P is parallel with the plane, and block B is hanging freely. The coefficient of friction, so mu, is 2/3. The blocks are released from rest with the string taut. A moves up the plane. The tension is T. The blocks are modelled as particles and the string inextensible. So show that T equals this. So we'll start by drawing the forces on the diagram. So we've got a mass of 2m, which means the weight is the mass times gravity. So it's 3mg and 2mg. They're the weights. We've got these tension forces pulling A up and resisting B. We have a friction force which opposes the motion, which is mu times r. The maximum friction is mu times r, and mu is 2/3, so it's 2/3 r. And the normal reaction acts perpendicular to the plane, so that's r. So there's our forces. We can start working out things now. So we'll start by finding r, and to do that we're going to take the forces perpendicular to the plane, so in this direction. So forces up should equal the forces down, because it's not going to move up or down. And this angle in here is alpha. So that angle there is alpha. So for part A, we're going to take the forces perpendicular to the plane. So we're saying forces up equal forces down. So R is the force going up, and that's equal to the force going down, which is part of this 2mg force, and it's the angle is in between our green line and the force. That makes it a cos. So this part of the force is a cos, and the part acting in the direction down the plane will be our sine part. So it's 2mg cos alpha. So we're splitting this 2mg into two different parts, a cos and a sine. So 2mg cos alpha. 2mg cos alpha. Cos alpha is 12/13. So it's 2mg times 12/13. And 2 times 12/13 is 24/13. 13ths. So that's our R force. Now we can look at the equations of motion for A and B. So we've got F equals ma. The force is equal to the mass times the acceleration. So let's look at either one of these. So let's look at A first. F equals ma for A. So for A, F equals ma. So the forces, which is going to be the force pulling it along, is just this T force. So we've got T, and then opposing the motion, we've got 2mg sine alpha. So minus 2mg sine alpha, and minus 2/3 of r. So 2/3 of 24/13 mg. So the friction, 2/3 of 24/13 mg, and that equals ma. So for A, the mass is 2m, and A is, well, A, the acceleration. Sine alpha, we can simplify this. So sine alpha was 5/13. And I'll just leave this as it is, and we can simplify it on the calculator. So we've got, I'm going to leave the mg's as they are. So I'm going to have 2 times 5/13, or negative 2 times 5/13 minus 2/3 times 24/13. So they're both in terms of mg. And that is negative 2. So I've got T minus 2mg equals 2ma. Now I can do the same for B. So for B, F equals ma again. And going down, the force with the motion is 3mg, and opposing the motion is T. So that's the force, 3mg minus T. So 3mg minus T equals, the mass is now 3m, so 3ma. So I've got these two equations. I want to eliminate A, so I want to get T by itself, and my answer's in terms of mg. So I'll divide my A equation by 2 and divide my B equation by 3. So I can say T, where should I write this? So my A equation, T minus 2mg over 2 equals ma. And for my B equation, 3mg minus T divided by 3 equals ma. So they're both equal to ma, so they must equal each other. So T minus 2mg over 2 equals 3mg minus T over 3. Multiply both sides by 2 and multiply both sides by 3. So 3 times T minus 2mg equals 2 times 3mg minus T. Expanding the brackets, so 3T minus 6mg equals 6mg minus 2T. I'm going to add 2T to both sides. So 5T minus 6mg equals 6mg, plus 6mg to both sides. and divide both sides by 5. And that is what we wanted. After B reaches the ground, A continues to move up the plane until it comes to rest before reaching P. Determine whether A will remain at rest, carefully justifying your answer. So B's hit the ground, A's continue to move up and eventually come to rest. So now there is no T force because this string will be loose because it's continued to move up the plane after B's reached the ground. So there's no T force anymore. So the only forces we've got left are this 2mg going down so we have our block with mass 2m. We've got the force 2mg going down. We've got the normal reaction up, and we have a friction force. Now the friction force will be opposing the motion, so it's going to be going up the plane now. This block is going to want to move down the plane, so friction will oppose that motion. So R is still the same as it was. R is still equal to 24/13 mg. And friction, the maximum friction, so friction max is mu times R. So 2/3 times 24/13 mg. That's the biggest thing friction can be. And let's simplify that. So 2/3 times 24/13 is 16/13. So that's the biggest thing friction can be. So that's the force acting up the plane. The force acting down the plane is 2mg. Force down the plane. So 2mg sine alpha. Sine alpha was 5/13. So 2mg times 5/13, which is 10/13 mg. So friction is, the maximum friction is bigger than the force going down the plane, so it will remain at rest. So 16/13 mg is bigger than 10/13 mg. So what did the question say? Will it remain at rest? Yes, it remains at rest. Max friction is greater than the force down the plane. And part C suggests 2 refinements to the model that would make it more realistic. So this is asking about the modeling assumptions that have been made. So let's have a look. 2 blocks A and B attach to the ends of a light string. So that's 1. So the string has been modelled as light. That means the string's got no weight. The string passes over a smooth pulley. We could have friction in the pulley. The blocks are modelled as particles. So the blocks are just modelled as little dots. So they could have a size. And the string is modelled as inextensible. So the string could be, or the opposite of inextensible is extensible. So they're our modelling assumptions. So we need to pick two of these. So the light string so we can write the string could be given a mass, so it's not light, or we could say, we could pick any of the assumptions. So we could say this, the pulley could have friction. The pulley could have friction, so not be smooth. Not be smooth. So we're just picking two of the modelling assumptions and saying, to be more realistic, we could have not used the assumptions we've used. Question 4. So here we have a ramp AB, length 8 meters, mass 20 kilograms, resting in equilibrium with end A on a rough, say friction, horizontal ground. The ramp rests on a smooth, so no friction, solid cylindrical drum, which is partly under the ground. The drum is fixed with its axes at the same horizontal level as A. The point of contact between the ramp and the drum is at C, where A to C is 5 meters, as shown in the diagram. The ramp is resting in a vertical plane perpendicular to the axes of the drum at an angle theta to the horizontal, where tan theta equals 7/24. So if we've got a right angle triangle and theta here, tan is opposite over adjacent, so opposite over adjacent. So we can work out the hypotenuse. It's a Pythagorean triple, so it's 25. So if we did 7 squared plus 24 squared and square rooted it, we would get 25. And we can use this to find our cos theta and our sine theta. The ramp is modeled as a uniform rod, which means the weight acts in the middle of the ramp. So let's draw our forces on. So the weight, so it's 8 meters long, so the weight will act 4 meters in the middle, so 4 meters, so 20 G, so the mass times G, 20 G. We have the normal reaction at C and the normal reaction at A, so we'll call them RC and RA, and we have friction at A. So we have another force opposing the movement of the ramp. So friction, I'll just write F. So they are all of our forces. Part A says explain why the reaction from the drum on the ramp at C acts in a direction perpendicular to the ramp. So the reaction is just this force here. just a normal reaction. So that acts perpendicular. Why is that the only force acting? Because there is no friction force. The drum is smooth, so there is no friction force. The drum is smooth. There is no friction force. Part B, find the magnitude, this is the 9 marker, this is the big one, of the resultant force acting on the ramp at A. So we want, well, both of these forces, and we'll do Pythagoras on them. So we'll find out what they both are individually, and then resultant force will be both of them together. So Pythagoras on RA and F. So we need to work out what they are first, and we can take moments about any point, and we can also do forces up equal forces down because our ramp is in equilibrium. So if we take moments about A first, so we need forces perpendicular to the ramp. So this is going to be another theta in here. So if we take moments about A, we can find the reaction at C, and then we can use forces up equal forces down, and forces left equal forces right after that. So let's take moments about A. So taking moments about A, so we've got our clockwise moments equal our anti-clockwise moments, and our moment is going to be the distance times the perpendicular force. So clockwise, we've got 4 times 20g cos theta. So clockwise, 4 times 20g cos theta, and anti-clockwise is 5 times the reaction at C. So 5 RC. Cos theta is, cos is adjacent over hypotenuse, so 24/25. Cos theta is 24/25, and we might need sine theta later, so 7/25. So it's 80g times 24/25 equals 5 times the reaction at C. So 80 times 24/25 is 76.8. So 76.8 G equals 5 times the reaction at C, divide by 5, 15.36. 15.36 G is the reaction at C. Now we can use forces up equal forces down to find our reaction at A, and forces left equal forces right to find F. So this time we want the forces acting up and down. So this is our theta now. So for forces up equal forces down, so up equals down, we've got RA plus RC cos theta, reaction at A plus the reaction at C, which we just worked out, times cos theta is equal to 20G. The reaction at A is what we're working out, and we've got reaction at C, which was our 15.36 G, times cos theta, which was 24/25, equals 20G. So 20 take away this. So 20 take away our answer times 24/25. So 20G take away our answer times 24/25 G. So our answer will be in terms of G. And I've got 5.2544 G. So the reaction at A is 5.2544 G. So that's the reaction at A. And then to find the friction force, we can do forces left equal forces right. So going to the left, we've got RC sine theta. So the reaction at C, which was 15.36 G, times sine theta, which was 7/25, times 7/25. So that's RC sine theta equals friction. So that's equal to our friction force. And we will simplify this. So 15.36 times G. I'm just going to leave it in terms of G as long as I can. So 4.3008 G. So friction is 4.3008 G. So I've left them in terms of G as long as I can. And now I know both the forces. I know the reaction at A and I know F. So I'm going to find the magnitude, which is Pythagoras. So I'm actually going to store these in the calculator now. Times 9.8 for G. So 51.5 stored as A. So this is 51.5 newtons. And we've got 4.3008 times 9.8 for G. 42.1 stored as B. 42.1 newtons. So for our magnitude, so the magnitude is going to be the square root of 51.5 squared plus 42.1 squared, square root of A squared plus B squared, which is 66.5 newtons. Given my answer to 3 significant figures, and so the ramp is still in equilibrium in the position shown in figure 2, but the ramp is not now modelled as being uniform. The centre of mass is assumed to be closer to A than B. So the weight is moving down further towards A. State how this would affect the magnitude of the normal reaction between the ramp and drum at C. So if this force was, also the moment's about A, so the distance times the force would be lower, so the reaction would be smaller. So the moment, so this distance times force would be smaller. So in our first calculation we did, so this would be smaller, which means RC would be smaller as well. So the reaction at C would be smaller. So we just need to say that. We just need to say the reaction at C would decrease, be smaller. Question 5. So we have points A and B 50 meters apart on a horizontal ground. When t equals 0, two small balls, P and Q, are projected in the vertical plane containing AB. P is projected with a speed of 20 meters per second at an angle of 30 degrees to AB. Q is projected from B with a speed of u meters per second and an angle of theta to BA, as shown in the diagram. At time t equals 2, P and Q collide. Until they collide, the balls are modelled as particles moving freely under gravity. Find the velocity of P at the instant before it collides with Q. So we've got t is 2 seconds and P is projected with a speed of 20 meters per second and an angle of 30 degrees to AB. So we take two different motions here. We've got a vertical motion and a horizontal motion. So let's look at those separately. So vertical, and I'll write suvat, and we've got horizontal, and I'll write suvat again. So what do we know? So we know time is 2 seconds. The acceleration, so the acceleration is going to be gravity minus 9.8 acting down in the vertical direction. So I'll put minus 9.8. And there's no acceleration in the horizontal direction. So the speed is going to stay the same. The velocity horizontally isn't going to change. So what is that? So it's 20 cos 30. So that's in the horizontal direction. And in the vertical direction, 20 sine 30. So because there's no acceleration, V will also be 20 cos 30 here for the horizontal motion. But we need to work out V for the vertical motion. So let's do that. So we can use V equals U plus AT. So we've got 20 sine 30 plus minus 9.8 times 2. So it's going to be negative. Positive times the negatives are negative. And 9.8 times 2 is 19.6. So we've got 20 sine 30 minus 2 9.8s, 19.6, and that's minus 9.6. So it's minus 9.6 meters per second. So it's moving at a velocity down 9.6 meters per second. Horizontally, it's 20 cos 30, which is 10 root 3. So I just write 20 cos 30 is 10 root 3 meters per second. So we've got our ball moving 10 root 3 across, 9.6 down. So let's make that into a triangle. So we've got 9.6, 10 root 3. and we want to know the velocity. So we're going to work out the angle here. So what's the angle and what's the length? So what's this hypotenuse here? So the angle, I put x, so tan x is opposite over adjacent, 9.6 over 10 root 3. So shift tan 9.6 over 10 root 3, 29.0, or just 29. So x is 29 degrees. So down 29 degrees, and 10 root 3 squared plus 9.6 squared square rooted. That will be our speed. So 10 root 3 squared plus 9.6 squared square rooted, 19.8 or 20. So I'll call this speed S, 19.8 meters per second. So the velocity is 19.8 meters per second at an angle of 29 degrees down from the horizontal. So 19.8 meters per second at an angle of 29 degrees down from horizontal. Part B, we want the size of angle theta and the value of u. So we know where it is after 2 seconds. So we can use that to work out u and theta. So we'll have to work out where it is first. So we can use these to find out the position. So let's do that. So part B. So let's do horizontal first. So S equals UT, and I put plus half AT squared. But remember, A is 0 in the horizontal. A was 0, so S is just 20 cos 30 times 2. So 2 times 10 root 3, which is 20 root 3. So 2 times 10 root 3, 20 root 3. And in the vertical, so all this is for A or P, this is for the P ball. In the vertical, S equals UT plus half AT squared again. So we've got U was 20 sine 30. T was 2, so 2 times 20 sine 30 plus half of minus 9.8 times 2 squared. So what's that? So 2 times 20 sine 30 plus half times minus 9.8 times 2 squared, 0.4. So 0.4 meters above the ground and 20 root 3 meters along. So it's 50 minus 20 root 3 from B. So from B, and the particle was called Q, (50 minus 20 root 3 meters horizontal and 0.4 meters vertical. So we know where it is, we know the distance. We need to work out u and theta now. So let's write SUVAT again. What do we know? So horizontal, we know the distance is 50 minus 20 root 3. We know u is u cos theta. V is also u cos theta because A is 0 and T is 2. And vertical, we know S is 0.4. U is u sine theta. We don't know V. We know A is minus 9.8 and we know T is 2. So again, we can form equations. So S equals ut plus half at squared, but A is 0. So we've got 50 minus 20 root 3 equals 2u cos theta. And S equals ut plus half at squared. So 0.4 is 2u sine theta plus half times minus 9.8 times 2 squared. So now we want to either eliminate u or eliminate theta. Let's simplify this first. So we've got half times, so 0.5 times minus 9.8 times 2 squared. So we've got minus 98 over 5. So 0.4 plus 98 over 5. So adding this to both sides. Or minus is 20. So we've got 20 equals 2u sine theta. We can half both sides. So 10 equals u sine theta. And again, let's half both sides over here. So 25 minus 10 root 3 equals u cos theta. We want to eliminate u or theta. If we divide one equation by the other, so have the sine equation over the cos equation, we will eliminate u. So let's do that. Let's have, so 10 over 25 minus 10 root 3. So we're dividing, we have this equation divided by this equation. So 10 over 25 minus 10 root 3 equals, so we've got u sine theta over u cos theta. The u's are going to cancel, and sine theta over cos theta is tan theta. So that's shift tan. So we want shift tan of 10 over 25 minus 10 root 3. And that's 52.5. So theta is 52.5 degrees. And we can use that answer now. We'll put it back into this. So 10 equals u sine theta. 10 equals u sine theta. So u is going to be 10 divided by sine 52.5. So 10 divided by a sine answer. 10 divided by a sine answer is 12.6. So it's 12.6 meters per second. So there we've got theta and u. State one limitation of the model other than air resistance that could affect the accuracy of your answers. So what modeling assumptions have we made? So the balls are modeled as particles moving freely under gravity. We could also say that we've used 9.8 for G, so we could use a more accurate measurement. But let's just say the balls could be, so the size of the balls could be taken into account. They could not be modeled as particles. So the size of the balls could be taken into account they could not be modeled as particles.